So let's get started. Let's understand what do you mean by recursion. You like or you do not like. Without recursion, you cannot mostly write in data structures. Mostly 60% of the problems you can easily identify through recursion. So most of the cases, you will get the analogy and the way to solve the problem through recursion. Whatever problems you pick up, either it is dynamic programming or graphs, trees, whatever it is, most of the cases you will get tough problems in those concepts, but which can be solved only through recursion. So initially we will find out a analogy or logic through recursion, then we can convert that into iterative logic. Let's see how it works. So in recursion, right, you pick up any programming language. Generally you write a logic within a method, right? So for example, you pick up any programming language. Assume that you have a Java code. So whenever you run a Java code, it will internally create a process. So we call it as a process. So your program will run in a process, and within a process, JVM internally creates a thread. We call it as a main thread. So a small unit, we call it as a thread. We call it as a main thread. So for each thread, right? So if you create a thread, there will be a call stack. So for example, you have T1, T2, T3. So when you create a thread, there will be a call stack. So we can call it as a stack. So for each thread, a separate stack will be created. So within a Java program, for example, when you try to run a Java code, so there will be a process. uh, Within that process you can create any number of threads. So by default, JVM creates one thread. So in generally you speak, for each thread, for example, if you create a thread manually, so for each thread separate stack will be created. So this is your stack. And whenever you run a code, right, whenever you run a method, whenever you call a method, so that method execution will always happens within a stack. For example, you have written a simple code, something like this. You have written a class sample, and you have a main method, and you have written some logic. So this is a simple code. So in general, when you run this code, how does it work? So JVM will create a process. You can call it as a process to run this code, and under this process there is going to be a thread which is internally created by main JVM. So we can call it as a main thread. So it will create a main thread. So as a thread is created, so for each thread separate stack is going to be created. So this is your stack. So if you create one more thread within this code, for example, if I create one more thread, so there will be one more stack will be created here. So here in simple, so you didn't create any thread, so the JVM created a thread, so separate stack is getting created within this stack. So what it does is it will create a thread to call this main method. So threads are usually meant for to initiate the logics. You return the logic within a method. So what JVM does is it will create a main thread and call this main method. So once the main method is called, so once JVM thread main thread is created a stack, then whenever main method is called, so this main method will be stacked here. So we can call it as a stack frame. So we can have a main method here. So we call it as a stack frame. So within a stack frame, the method execution will happen. So what will happen? So within a stack frame, all the local variables, right? So you have a local variables, whatever variables you declare within a method. So local variables initialized, or sorry, not initialized, memory allocation for local variables will be happened within a stack frame. We can call it as a memory allocation. So it happens a memory allocation, and once that stack frame, once a method execution completes, right, stack frame will be terminated. So when this is your stack frame, right, there are two cases. The stack frame will be terminated in two ways. One is uh, when uh, execution reaches end of the line. So it means once you gets into the end of the method, stack frame will be terminated. Or there are another ways is whenever it finds a return keyword. So either of the two cases, the stack frame will get terminated. This is how why we need to talk about stack frame, right? The complete recursion works through stack frames. So in recursion, the simple way in recursion, how do you do recursion means what? You wanted to make a communication between the methods. So you have a m1, and this m1 will take some input, and it will return the result. So it will give the output. This output is going to be the input for one more method. So the same method will be called in recursion. How does it work is you can recursively call the same method uh, until you get the result. So this is how you pass the initial input, and this m1 method will be executed. Then it will generate an output. That output is going to be the input for new recursive method of same m1. Again, this will take that input, and it will this is going to be the input for here. So and this will generate a output, and that is going to be the new input for m1. So recursion means unless, so you recursively call the same method until you reach the base case. Let's say one example. For example, you got a use case. You got a use case. You want to print numbers uh, from 1 to n without using any loop. How do you do that? So uh, you should not use any while loop or for loop or any other loop. So we need to print numbers from 1 to n. So without using any loop, how can you do that? For example, if I give n equal to 5, so the expected output is 1, 2, 3, 4, 5. Okay, so let me, yeah, so one way is we should not use any loop, right? So one way is we should not use any loop. Then I want to print the numbers. So the only solution is definitely to print numbers from 1 to n. The one n value should be I need, for example, when you write a for loop, right? So you take one initial variable as I, which is starting from 1. So this is how you do it, right? So I, which is starting from 1 to n, then you print I, right? So in this case, what is happening? So there is a I variable which is keep on changing, and I'm just getting that I, right? So I'm just getting that I. I'm just printing that I. So if I don't want to use any loop, then how can you do that? So that's where you get into the recursion. So what I do, so I'll go with a method called print. Initial I'll take 5. And this is not the time I need to print the 5, because I want to print numbers from 1 to 5. So then what I do, I will call a method calling n minus 1. So here n equal to 5. So this is the local variable, you can say. It is a local variable. For this local variable, memory will be allocated within a stack frame. So initially it is 5. So this is, I want to print 1 to 5, so that what I do, I should not take a decision of printing. So that before that, what I does, I'll call a method of n minus 1, so that it internally called 5 minus 1, so which will internally call same print method with the value 4. Then what it does, I will call again, this is not the right time to print the value. Why? My use case is I want to print numbers from 1 to n, right? So not n to 1. So that initially n is 5. Then as n is 5, so I am moving further. So I call a print method with 4. Then this is also not the right time. I call a method 3. Then again, this is not the right time. Then I will call a method of 2. It means this is n minus 1. That's it. So then I will call a method of 1. Now you see that I am reaching the base case, right? So if you closely see, I am reaching the base case. So here value is 1. So I am reaching the base case. This is called a base case. So in recursion, right, you cannot invoke the methods blindly. So whenever you write a recursive logic, you should know when to start the execution, when you stop the execution. So when to start, where to start, when to stop. So in this case, I want to print numbers from 1 to n. N was given, so that I need to print in a ascending order, right? So but I got the higher number, so that I went calling the same method until I reach 1. So once I reach 1, so I understand that this is the base case. As this is the base case, it is time to get the result. So what I do, I'll just do sysout of 1. Then I will just terminate this stack frame, so I'll just call return. So when I when I so there are two ways. So the stack frame will get terminated in two ways: whenever it finds a return keyword, or whenever it is moving to the end of the line. So as I return this stack frame will get terminated and the cursor will move on here. So generally how does it work? So first let me write the sample code so that you can visualize it in a better way. So simple. So I am trying to print numbers from 1 to n, right? So I'll take a method called public void print, which is n. And I'm sure that whenever my n is reaching, okay, so whenever my n is reaching 1, so whenever I my n, so before that, what can we do? So you can call simply print of n minus 1, right? So what it does, then I want to print 1 to n, right? So that this is n equal 5, 4, 3, 2, 1. So whenever it is reaching 1, so I should not call n minus 1. So I should not print 0. So that what I should do, I should make a base case that if my n is equal to 1, then I should not proceed further. So I'll just make a return statement. So I'll just call return. So when n becomes 1, I just call return, so that but if you, so let's say when my use case is invalid, so when n becomes 0, so I should not go further, so that I should not print that value. So when n becomes 0, I will just call return. So this stack frame will get terminated, so this will not get called. Otherwise I'll just print sysout of n. Let's see how does it work. So initially you called a stack frame with print of 5. A stack frame is called with print of 5, so that here n equaled 5. So whatever value you passed, so here n equaled 5. As n is not equal to 0, so that you are internally calling n minus 1. So obviously it is going to call print of 4, because here n minus 1, you internally, it is internally calling print of n minus 1, right? So it is internally calling print of 4. So if you see here again, n equal 4 here, so 4 is not equal to 0, so that it is going to call print of n minus 1. So it means it is calling print of n minus 1. So it is going to call earlier n equal 4 here, so at this block n equal 4 here, so it is calling print of n minus 1, means it is called 3. So here n equal 3. Again it comes here, again here n is not equal to 0, so that what it does is it is going to call print of n minus 1. So okay, so it will call print of 2, so here n equal 2. Again it comes here, so here also n not equal to 0, so that obviously it will call print of n minus 1, so that it will call print of 1, so that here n equal to 1. Closely observe. So again here n is not equal to 0, so here in this case n is not equal to 0, so that it will call print of 0. So it will call print of 0, here n equals 0. Closely observe, throughout this case, right, none of the stack frame got terminated. So because in the middle of the method we are initiating the another method. So this is how we are doing throughout this code, throughout this flow. There is no stack frame got terminated. Now if you see here, n value is 0. So when n value is 0, we are just returning the return keyword. So whenever it finds a return keyword, this stack frame gets terminated. Whatever the code present after that, right, none of the code won't be executed. So simply it terminates this stack frame. Okay, so this stack frame gets terminated. It means if you closely see, this method is being called at this line, right? So when n equal to 1, so you verified n is 1. As n is 1, n is not equal to 0, so that you called print of 0. And print of 0 means here n equals 0, so that you call return, so that this stack frame gets terminated. Now here it means this line is executed. So this line is executed. So it's time to execute the next line. So in this stack frame, so in the next line you have sysout as n. So here n equal to 1, right? So sysout of n means it prints 1. Again, once it is reaching end of the line, so that this stack frame gets terminated, it moves here. So once it moves here, so earlier from this stack frame, this is where the execution is redirected to the print of 1, so that execution is completed, so that it's time to print the n value, so that n value will be printed to 2. Again it is reaching end of the line, so that it is moving here. Now again, so when n equal to 3, you called print of 2, so print of 2 execution is completed. It's time to print current n value from this stack frame, so which is 3. So once this done, it is just written here, so that it's time to uh, move here. So here n equal 4, obviously here you print n value as 4, then it moves here, obviously you print n value as 5. So what did you understand here? So in a recursion, we are calling the same method recursively until it reaches to the base case. The more important point is, we should know where to stop, right? So we should know where to stop. So here n is 0. When the n is 0, our use case is invalid. So uh, that base case we should identify whenever you write a recursive logic, and just go with the flow. So do you get it right? I think you understood, right? Okay. I know you might have been through this couple of times, but this is something which is very basic to write the code. Let me. Okay. Simple. For example, if you want to find, just write public. Okay, let's say class sample. So print, simply it will take n. So this is what we did, right? So we just need to call print of n minus 1, because I get n, so that I need to call 4 3 2 1, and I'll just print, at last I'll print the value. So this is how it works. But more importantly, we should know when to stop the recursive call. So simply we can call whenever our n is going to 0, it is invalid, so that I'll just stop the recursive call. This is how it works. So if I want to print n to 1, for example, this is the use case of printing numbers 1 2 3 4 5. So if I want to print in reverse orders, what should I do? Can you tell me? Any idea? If I want to print numbers in reverse order, can you tell me what to do? Yeah, that is for sure. Yeah, if I want to write the same print logic, okay. Where is the change is needed in the above method? Yeah, that's it. So the use case again same, right? So whenever n equals 0, so it is reaching to the base case, I can return. So prior to that, just print it. That's it. So what it does, if you closely see, this is how happening, right? So first it will call print of 5, then what it does is prints 5, then call print of 4. So that's how it works, right? So print of 4, then again it is prints 4, then call print of 3. So that's how it works. So that's how it works. So that is how recursion works. In recursion, mostly what we do, we make a communication between the methods. So the same method output can become an input to the next method. So, for example, if I want to find a factorial of a given number, right? So how do you do that? Let me trace out here. Okay, so generally, if you closely see 5 factorial, so the 5 factorial value generally how it is 5 into 4 into 3 into 2 into 1, right? So when n becomes 0, so it is invalid. So obviously it is invalid. Or when n equal to 1, you can simply return 1. So it's up to how you want to define the logic. So this is the factorial method. So how do you do that? So let's see here. Generally you will get fact of 5. Okay, so generally this is our fact of 5. How do you write the recursive logic here? If I write the logic, right, it is easy to track it. So if I write the logic first, then I explain the flow, it is very easy to track. But as we already know how to print the numbers, right, can you tell me how can we do that to find out a factorial? Here, what is a change you could observe? What is the change you could observe? So let's say how do you divide this? So this is your code, right? So can I write it as 5 into 4 factorial? Then can I write this as 4 into 3 factorial? And this I can write it as 2 3 into 2 factorial. Then this I can write it as 2 into 1 factorial. Is it clear? Can I write this way? So if you see, I am trying to track. So this is my main problem, 5 factorial. So closely observe. So this is my main problem. So 5 factorial. What I am trying to do, I want to get the 5 factorial. So I am dividing this main problem into possible subproblems. So I am just writing 5 into 4 factorial. And this is my main problem, but I want to divide this into possible subproblems. So assume that this is my main problem now. So I want to divide this into possible subproblems. Then I'll just write it as 4 into 3 factorial. Then again I divide this main problem into possible subproblems. So 3 into 2 factorial. And again this one. So I'll just write into 2 into 1 factorial. So that's it. So once I reach to the base case, this is 1. So I cannot divide into subproblems when 1 factorial value is 1. So that this is the possible subproblem I could get with respect to factorial. So that I can simply return 1 here. So now can you tell me how do you write the recursive logic here? How do you write? What is n minus 1? So what is this n minus 1 is representing? This is n minus 1, I understand. So what is this is representing? Then what it does? Okay, so it called recursively 4 factorial. It's fine. Then what it does? Okay, it will come till here. So what is the next thing you should do? Yeah, so the more important point is earlier what we did, so we are just trying to print the value, right? We are not returning any value. So in this case, the subproblem results will be used by the main problem. If you closely see, This is 5 factorial, right? So this is 5 factorial. So you are dividing the 5 factorial into 5 into, this is where the code will start. So 5 into 4 factorial. So to get this, I can call this as a fact of 5. So fact of 5, so what you are trying to do, you are trying to do 5 into 4 factorial. So I need a 4 factorial, right? To get the 4 factorial, what I did, I called fact of 4. So this fact of 4 will be called, so this fact of 4 is divided into 4 into 3 factorial. So I need 3 factorial. So to get the 3 factorial, I just call fact of 3. This is my sub problem now. So to get the, this will return 3 into 2 factorial, but I need 2 factorial, right? So to get 2 factorial, so I'll just call fact of 2. Now when I call factor of 2, so this is calling 2 into 1 factorial. So it means this is internal, I need this sub problem, so I will get factor of 1. Okay, let's say factor of 1. So here n value is 1, right? So when n value is 1, it will simply return the value. So when 1 factorial means what? It is 1 only, no? So it will simply return as n equal to 1, so it will just simply return 1. Okay, so it just returned 1. So it means this is a stack frame, right? If you closely see, everything is a stack frame. So this is everything, whatever you see here, so everything is a stack frame. So so what it does, whenever it is reaching to the base case, I am just returning the 1. So closely see, I am just returning to the 1 to the caller. So I just return 1 to this caller. So here is the caller. So it means fact of 1 place. So this 1 factorial is represented by fact of 1 method. So this fact of 1, uh, yeah, so this is fact of 2, right? So don't get confused. This is fact of 3, this is fact of 4, this is fact of 5. So if you closely see this 1 factorial, so for 1 factorial you got 1, so that obviously 1 factorial value into 1, 2 into 1, so which is going to be 2. So and this 2 will be written here, this 2 will be written here, this 2 factorial, this 2 factorial will be replaced with this value, so which is 2. Now 3 into 2, which is going to be 6. So this 6 will be written here, and this is internally represented by 3 factorial. It means factor of 3 method, so that you can simply replace with 6. Now which is going to be 24, and this will return 24, so that this factor of 4, right? 4 factorial means factor of 4, which is represented by this method. So you can just replace this 4 factorial value with 24, and this 24, which is going to be 120, so which will be returned to the caller. So the factor of 5 will be internally called by one of the method, and that will hold 120. Did you understand the flow, everyone? Everyone understood the flow? Okay. Now can you tell me how to write the logic? No, if I write a logic, it will be dead easy. So I don't want you to do that. I want you to think. Can you tell me how to write the logic? Now first tell me, how is the method signature now? How is the method signature? Yeah, it should have a return type, right? So in the previous case is different. In this case, we want to return sub method calls result will be used into current method. So we have a int return type, and it has a n. Okay. So what is the base case? Can you tell me the base case? What is the base case? Yeah. So where is it? So simple. So when n is 1, so you can simply return 1. Otherwise, what you do? So what are you doing otherwise? So this is where subsequent call happens. So tell me, if n equal to 1, we return 1. Otherwise, what we need to do? Tell me. That's it, right? So that is what we are doing, right? So if you closely see, this method can be called here n equal to 5, and we are calling 4 factorial, so which is n into fact of n minus 1. So that's it. So that's a principle we are trying to derive from here. Otherwise, we can return n into fact of n minus 1. That's it. So this will in turn find out the factorial. So what is the time complexity here? What is the time complexity here? Yes, order of n only, right? So because you are trying to initiate a logic for n times, so this is order of n. So what is the space complexity? Yeah, what is that space? Yeah, yes, that is only the thing here. So here, when you write a iterative logic, right? For example, if I write a iterative logic, I will write a logic within a for loop, and that happens within a single method. So it executes in a single stack frame. But in a recursive logic, right? So what will happen? In a recursive logic, what was happened here? So first you called a fact of 5. So there is a stack frame. For each method, separate stack frame gets created. So fact of 5 internally called fact of 4, and fact of 4 is internally called fact of 3, and this called everything is a stack frame, so which will call fact of 2, and this is called fact of 1. So everything is a stack frame. So there are yeah, if n equal 5, there were 5 stack frames gets created. So that this is going to take n space. How many n was there? So those many stack frames gets created. So that's why recursion definitely, for example, n equal to million. So definitely you cannot create million stack frames within your course. Your programming language don't support. Definitely it will come up with stack overflow exception. So recursion is ideally very good approach, but most of the if the n value is if the input size is really huge, we should avoid going with recursion. We should figure out a iterative solution. But most of the DP problems, right, DP and graph problems, it is very tough to come up with iterative solution unless you are strong into recursion, right? So hope you understood this base. Now let's understand, let's say, when to go for recursion, right? So let's understand when to go for recursion. More importantly, you want to see all possibilities. If you want to see all possibilities, you can go with recursion. So when do you know that I need to go with all possibilities? Possibilities means uh, there is a choice of elements, either you can include or you can exclude. So that's where you see the possibility, right? So when you have an input, there is a choice, either take this value or do not take this value. So kind of use cases you can blindly go with recursion. For example, let's say I have an input called let's say I have an input called 1 2 3. I want to print all subsets. What do you mean by subset? So generally, this is how subset we already know, right? So we already uh, subarrays we print, but this is subset. So let's say, what do you mean by subset? So first, every empty set is a subset of an array. Then you will have one, then you will have one two, then you have one two three, then you will have two, then two three, and then you have three. So these are the subsets of a given array. Simple. So you have one, two, three, then two, two, three, then three, and empty subset. That's it. So now we want to print all these subsets. So this is where we can think about recursion. Now, what did you understand? So if you closely see, this is your given output, right? So this is our output. If you pick up, if you see here, this is a current subset. So in this subset, uh, when we choose an one, it means there is a choice of element. You can pick up any subset. For example, you pick up this subset. I choose an 1 2 3. But if I pick up this subset, I choose an 2 3, but I excluded 1. But in this case, I choose an element 2, but I excluded element 1 and 3. It means when you have a choice of elements, right? So when you have a choice of elements, you can go with recursion. It means either include or exclude. So you want to include the current element or you want to exclude the current element. That is where the logic of recursion would work effectively. So let's say, how do you track this out? So let's assume you have an array of values 1, 2, 3, and you know that every element is internally identified by indexes 0, 1, 2. So whenever you are writing a recursive logic, it is very important that what is the input you are trying to take, what is the input you are trying to take, and what is the output which is going to generate. So which is more clear. So let's say, how do you tackle this? So generally, uh, initially, forget about empty subset so that we can add any time. So let's start from index 0. I am starting with index 0. I can include index 0 or I can exclude index 0. If I include index 0, so either I can include or exclude. Whatever you do, either you include or exclude, you will move on to the next index. So I need to take a decision to move on to the next index. Shall I include the current element or shall I exclude the current element? Forget about the result. Let's say how it works. Let's say you have I equals 0. So at I0, what is the value you have? If you include, obviously at I0 you have value 1, so that you will get value 1. If I exclude, so I don't get anything, so it will simply return empty. So if you closely see, this is this is your current input, right? So this is your current input. Better write it in better way. So whenever you are writing recursive logic, right? So this is, assume that this is going to be represented by your method. So whenever you are writing a recursive logic, think about what is the input it is going to generate, what is the output it is going to generate. For example, I am going to give empty subset to initiate a recursive method, and let's say I am starting from index 0. So this is my current input. So empty subset and index 0. I am starting from index 0. If you closely see what I said, so you pick up any subset, right? There is a choice of elements. If I pick up this subset, I included index 0 value, which is 1. I excluded remaining 2 values. In this subset, I included 1 and 2, and I excluded value 3. It means I included index 0 and index 1. I excluded index 2, right? So let's say, how does it work? So I am starting from index 0. You pick up any subset, you have a choice of elements. So that is where the recursion powers. So let's say I am at index 0. Now I have two options. I can include or I can exclude. So I can include or I can exclude. Let's say I include this current 0 to this input. So it means you already got a value. So for this I am including this current input. So if I include it, I'll definitely add that value to this current result, so that is going to be my new input. So I include it. So for this empty subset I0, you have value 1. Value 1 will be added. And if I exclude, obviously I will not get anything. So the same, whatever empty subset you have, same will be forwarded here. So now let's move on. So whether you include or exclude, you keep on move on to the next index. So I'll move on to the next index, so that I have next index value as 1. Here also, even I include or exclude doesn't matter. I'll move on to the next index. Okay, so this is my new recursive call. Now again I have two options. I can include or I can exclude. Let's say if I include, so if I include, if you see, for this array, for this recursive method, I have value 1, right? I am including current index value, so which is 2. So if I include, definitely the value will be appended to this result, so 1, 2. If I exclude, there is no choice, I'll simply get that 1. So obviously, whether I include or exclude doesn't matter, it is move on to the next index. Okay, so it's move on to the next index. Now again I can take a choice, whether I can include or exclude. So if I include I2, means at index 2 you have value, and at index 2 you have value 3. So that value 3 will be added to this input. So that 1, 2, 3. If I, so 1, 2, 3, so it is reaching to the, so 1, 2, 3. If you don't include, so definitely say whatever input you have, same will be forwarded here. Whether you include or exclude, it doesn't matter, you will move on to the next index. So this is where the base case. So our now our I is reaching end of the array, right? So it means you can return here. So this is one direction you move on. If you closely see, I started from index 0 and I am just doing include or exclude, either include or exclude. I am just moving on to the index 1. Again here I'll see include or exclude. I included, so when I include it becomes index 2 value will be added to this result. So I'll have 1 2. Then I move on to the further. So when I include index 2 value it becomes 1 2 3. When I exclude it becomes 1 2. Similarly do for this. I traverse this, I didn't traverse this one. So I want to include or exclude. So either you include, if you include, so you will get index 2 value is 3, so 3 will be added to this result, so which is 1 1 3. If I exclude, simply what it does, whatever 1 is presented, so the same 1 will come here. So either you include or exclude, you will move on to the next index, which is I3. So this is also reaching to the base case. Similarly, if you closely see here, either either I can include or exclude. So either of the cases I will move on to the next index, but let me track the result. So if I include, for this result index 1 value will be added, so which is 2. If I exclude, it will simply move on to the next one with the same input. Now let's move further. So here also I can include or exclude. So if I include 2, so index 2 value will be added to this result, so that which is 2 3. If I exclude, the same 2 will be forwarded here. So in this case also, which is moving to the next index. So it reaches to the base case, so that you can stop the execution, because I is equal to n. If you see here, I can include or exclude. If I include, the 2 value will be added here, so that it becomes index 2 value, which is 3 is added here. If I exclude, I'll just get the same empty subset. Here also I'll move on to the last index, so which is index 3. So if you closely see, this is what we did. So we got this one, this one, this one, this one, this one, here. Oh, sorry. Let me retake the diagram, so that things will be better. So let's say you have 1 2 3. So index 0 1 2 3. So what I'm trying to do, I start from index 0. So I have two options. I'll start with the empty subset. So I have two options, whether I can include or I can exclude. So if I include, so what will do, index 0 will be, value will be added here, so that the value becomes 1. It means index 0 value is 1, so 1 is added to this. If I exclude, it is simply moving into the same subset will be moved to the next recursive call. So either of the cases I will move on to the next index. Okay, I moved on to index 1. Now again I have a possibility of including or excluding. So if I include index 1, so index 1 value is 2, so 2 is added to this, so that the output becomes 1 comma 2. So it is move on to, if I exclude it, whatever input you got in the previous recursive call, same will be forwarded here. So in this case, again you will move on to the next index, I equal to 2. Okay, so I came here. Again same case, I can include or exclude. If I include, so the index 2 value will be added to here, so that it becomes 1 2 3. If I exclude, the same value will be forwarded here, so 1 and 2. So which is moving to index 3 now. Now you know that whenever we reach I equal to I, this is the base case, right? So when I value is reaching to the length of an array, so you can't forward further, so that you can break it. Now let's move further. So we solved this problem, so let's solve this problem too. Here you can include or exclude. If you include, for this value, index 2 value will be added. So index 2 you have value 3, so that 1 comma 3 will be added. If you exclude, same 1 will be forwarded here. So in either of the cases you get the same I3. So this is also reaching base case. Similarly, if you here, you can include or exclude. So either of the cases, if you include, index 1 value will be added to here, so that which is 2. If you exclude, same input. The more importantly, you need to understand what is the input this recursive call is taking. So this is taking empty from here. So for that result you are just adding current result. So which is reaching to index 2, again index 2. Now again you have two options, you can include or exclude. If I include, index 2 will be value will be added here, so that it becomes 2 comma 3, so which is reaching index 3. If I exclude, the same result will be forwarded here, so which is becoming index 3. Similarly here also, include or exclude. If I include, index 2 value will be added, so it becomes 3. If I exclude, same will be forwarded to next index. So I equal 3, I equal 3. So now we need to track what is the result we got at base case. This is our base case, right? This is our base case, right? So you see, this is our base case. Let's track the results we tracked at base case. So 1 2 3. Here also we got 1 2 and 1 3 and 1 and 2 3 2 and 3 and empty. So if you closely see, these are the results we tracked at base case. If you closely note down, so you have 1 2 3 and 1 2, and you have 1 3 and 1 2 3 and 2 3 and empty subset. So this is what we got. If you closely see, these are the subsets, right? So we got 1 2 3 1 2 1 3 1 2 3 and 2 3. So these are the subset we tracked. So it means whenever there is a choice of element, we need to take a decision whether I can include or exclude. So more importantly, in a recursion, what is the input you are taking, what is the output you are generating, so which is more critical. So this we need to keep in mind. Do you understand the flow, everyone, or is my diagram went into clumsy? Okay. Banu, Maithili, did you understand? Okay. So now tell me, how do you write the logic, right? So we will talk about time and space complexity later part. Can you tell me how do you write the logic? So what is the input it is going to take? What is the input it is going to take? Can you tell me? Yeah, so it is going to take, for example, it is wide. Okay, let me write in notepad. Uh, is it written? Yes, it should return an array, correct. So we will move on. Okay. So you have public integer array subsets. Okay. What it is going to take? It is going to take index, right? For sure, it is going to take index, and it is also taking current array. Yes or no, please? Yes or no, please? If you closely see here, this is representing current result array, right? Current input or not? Yes or no? This empty, this one, right? But the problem is, if you go with array, it is fixed in size. So that let me go with list. So I can take list of integers, current, then okay, so this is our current, and it's up to you whether, if you return it, right, it's tough to track every result. So what I does is, instead of returning it, so what I does is, I will just take a result. So I'll just take a list of integers. This is our subset. you can take it as a result. So all 8 subsets will be stored into this. So you will think about it, but if I return it right, it's tough to track that resulted value. So I'll just take result. So this will hold actually. Rather considering here, what it does is I'll just take here, and finally I will store the result. So I don't need to return, because if you closely see in the diagram, right, so once I reach to the base case, so I already got whatever subsets I need. I will just take that values, that's it. So, and you also need a current array. So this is your given array, this is your input array, and this is your current result, current state, you can say, whatever it is. Hope you get, hope you don't get confused. If you closely see in this diagram, at each recursive call you got a current state, you can call it as an input rather state. So this is input, and this is your input array, and this is your index. Okay, now can you tell me how to write the logic? Can you tell me how to write the logic? So there are two cases, right? So first, can you tell me what is the base case? Yeah, so one thing for sure, when index is reaching end of an array, so array dot length, what should we do? Tell me please. We should add it to the result, right? So yeah, so I can result dot add of whatever value you get input. So I'll just add this input. That's it. So I'll just do return. Okay, this is one way of writing the recursive code. The beauty is recursion logic you can write in n number of ways. So this is one way. You can try your own way. Okay, so now what is other case? So now you have two options, right? Include and exclude, right? Yes or no? You have two options, so whether you include or you exclude. So what do you do if you include? What do you do, man? What are you doing? If you closely see this diagram, right? So if you want to include, it means current zeroth value I want to include. If I want to include, what should I do? I must add current value to it, right? Yes or no? Please. So earlier it is empty subset. If I want to include, I either you can include or you can exclude, right? Either of, there are two subtrees, two branches. This index will be cut into two branches to move on to the next index. So one branch is it will include the current element, other branch is it will exclude the current element, right? So hope you are able to catch what I'm trying to say. So this current index is cutting into two branches, right? One is including, other is excluding. If I include, I can add the current value, so current index value to the result. If I exclude, I can directly forward the same result. Correct? Yes or no, please? Everyone is clear, right? Okay. So now I want to include. So if I want to include, so whatever instead of input, I'll take it as a list for better clarity's sake. So I'll just take list dot add of current element is present in current index, right? So array of index. Then what I should do, I need to call the same call subsets by moving on to the next index, index 1 with the same list and array. Okay. If I want to exclude, then what should I do? If I want to exclude, then what should I do? But we already added, right? We already added, right? Then what should we do? How do you remove it? So that is removing that element, right, is really tricky thing. Okay, so which is really tricky part. So what we do is I'll tell you about it. So that's a backtracking logic. This code will be modified tomorrow, but let's see I want to include. So if I want to include, then what I'll do, uh, okay, so first what I do, I'll just take new array. I can take it as a temp list. So integer temp list, which is going to be new array list of same list. So whatever list I have. So this is my temp list, because when you include, this will definitely modify the result, because if you closely see here, right, in this case, this is including, this is excluding, so this is including, this is excluding. So when you include an element, it is actually modifying the actual input, so that when you exclude, the actual input should be forwarded to the sub list, sub call, so that I am taking that temp I'm taking that current input into the temp list. Okay, so when I include, so I will take the current input and add the current element. What is it, array of index, right? I'll add the current element, I'll move on. If I exclude, then what I'll do, I'll just write subsets. I'll move on to the next index. Whether you include or exclude, you will always move on to the next index. Then when you exclude, you should not add to the current result, will not be added to the list, so that the exact value is present in temp list. I'll take that temp list and I'll move on. That's it. So do you understand? So this is the code actually. This is the code, it will print all the subsets. Do you have any questions? Okay, let me submit this code. We already have this code. But this needs a lot of tuning. We will do the tuning. Uh, okay, so what I'm trying to do, I'm taking a variable. It needs a lot of tuning, so we will take care of it. New array list. So let me copy that code. That's it. So at last, okay. We'll keep the same. Actually, we should just need to copy this method. That's it. So we will just call this method subsets. So what is the initial input? If you closely see, this is what the initial input, right? We pass index 0 with empty list, right? So that's what we are trying to do. So we are starting from index 0 with empty list. New assume that array list, whatever it is, with empty list. Then we will also pass the same input array. That's it. So what it does, whenever it is reaching to the base case, whatever data it is getting in, so it will just add to that result. You can call it as result. So result dot add of list. So it will just add to the result. Then finally, this result will hold the complete data. So at last, we can simply return result. Okay, that's it. Let me format it. Everyone, please do practice this subsets. Please practice this, because one update is we'll have session every day. It is very tough to complete if you don't maintain the session every day. So every weekdays, Monday to Friday, we'll have sessions. I will just update that calendar. The problem is, if there is a gap now, it will be very tough for me to sync it. So better we'll maintain continuous Monday to Friday. Whenever I feel tired, we can post on that day. So I wanted to hear from you. Is that fine? Okay, before that, can you tell me what is the time complexity here? So for recursive logics, right, identifying the time complexity, it is really tough. It's really tough. Uh, let's see how do you do that. So I'll take 5 minutes extra. So what is happening here? If you closely see, you have you start from I0, then you included, excluded, you went on to I1 and I1. Then you included, excluded, you went on to I2 and I2, and you included, excluded, and you went on to same case here also you went on to I2, I2. Then you included, excluded, you went on to I3, I3, here also I3, I3. So included, excluded, included, excluded. Okay. So the more important point is, though how many method calls you have, there are many method calls, so every pointer is one method call itself. Don't worry about how many method calls it has. At any point in time, this is our final result, right? So this is our final result. So how many final results we got? We'll talk about time complexity. uh, can you tell me what is the time complexity? If you closely see, this is our final result, right? So at last level we have a final result, right? So till here you move on. So we have n equal to 3. It went into uh, the final result, the final possible sub problems you get it as 8, right? So because this is the sub problem result, right? So this is where you got the result. This is where you got the result. So these all are sub problem results. You divided the main problem into possible sub problems. This is where you identified the sub problems. What do you mean by sub problem? Where you cannot divide further. So this is where you can't divide further. You took n is 3. It is divided into 8 sub problems, right? Correct? Do you understand me what I'm trying to say? So it is divided into 8 sub problems. Now it means when n equal to 3, it is divided into 8 sub problems. So you can take it as 2 power n equal to 8, right? So 2 power 3 equal to 8. It means obviously when to generate a subsets, right? So when generally in simple, when n for n array, the number of subsets you can have as 2 power n. So obviously in this case, to generate all the subsets, obviously you need a 2 power n sub problems. So one for sure is the time complexity is 2 power n. And what is additional thing we are doing for each sub problem? What is the additional thing we are doing? Can you please think about it? For each sub problem, if you closely see, this is our sub problem, right? Yes or no? This is where the sub problem will be terminated, right? Yes or no? At line number 12 to 15, correct? Everyone? So what are we doing there? Okay, so we understand that there are 2 power n sub problems. For n subsets, there will be 2 power, for if length is n, you will generate 2 power n subsets. Obviously you generated 2 power n sub problems. So time complexity is 2 power n. And what additionally we are doing for each sub problem? What are we doing here, please? So we are also copying the result, right? Yes or nobody? Please, we are also copying the sub problem results into the actual result, right? This list is sub problem result, na? Yes or no? Each recursive call result, na? Everyone, Akash, Ajay. Right, so that list is sub problem result. It means what could be the, whenever you are copying the result, right? It means there are there are 2 power there are 2 power n sub problems. For each sub problem we are copying the result, right? Copying results. So what could be the worst case? What is the size of a what is the size of the input result in worst case? What is the size of input result in worst case? Yes, right. It will be n, right? So it will be n because in worst case you have 1, 2, 3, right? So which is equal to n. It means we always, every time we are copying the input result, we every time for each sub problem we are copying the input result. In worst case, what is the size of the input result which is to be considered? So one time we copy one element, two element, three elements, doesn't matter, but we should consider the worst case. In worst case, we have n results, n input elements will be copied to the sub problem, so that the time complexity is n into 2 power n. Is this clear? Is this clear, everyone? This is really tricky. Okay, so the time complexity is n into 2 power n. Good. Okay. Now, what is the space complexity, right? This is the first problem. Some you may feel little tough to digest, but when we keep on doing problems, right, so you will get habituated. So I want to know that the space complexity. One thing you need to understand: doesn't matter how many recursive calls you generate, right? How, doesn't matter how many recursive calls you generate at a time. Only what are how many active calls will be there on the memory, which is talking about recursive logic. So in this case, if you closely see, this is also very critical to understand. I0, you include. First, this flow will continue. So once you include, so it will go on to I1. Then you include, it will go on to I2. Then you include, it will go on to I3. Now, which is reaching to the base case, so that this will get terminated. This will get terminated, so that it will move on to the exclude. So for this exclude, do you understand what I am trying to say? If you see the logic, right? If you see the logic, first you are calling the include logic. Once this get terminated, then you are calling exclude logic. So that is what I am trying to do the same here. So first you have 0, you included, then it will come to 1, and 1 is included, it will come to 2, then 2 is included, it will come to 3. Once it is reaching base case, this will get terminated, then it will move on to the to exclude logic. So it will come here. Again it will get terminated. Then once these two get terminated, then it will move on to the exclude logic of this I1, so that it will come I2. Again same logic. So here also you include, if you include, it will go to I3. So once this get terminated, it will move on to the exclude. Do you understand what I am trying to say? Everyone please. You have lot of recursive calls, but at any point in time, how many stack frames get activated? At any point in time, only n stack frames get activated, right? Yes or no? This is to be very clear. Please, everyone is clear on it. Let me know if you didn't get it. I can re-explain it. Everyone is clear? Let me explain one more time. Banu, Kalyan, Ajay, Maithili. Yeah, yeah. So what are we trying to do? We wanted to know at any point in time how many stack frames gets activated. So that's the point. So first we start from 0. Through the code, what are we trying to do? If you closely see through code, what are we trying to do? So we take up a first we do include. Once include is completed, then we move on to the exclude. So it's not parallel processing. So it's a sequential thing, right? So once the include is completed, we move on to the exclude. So now if you closely see, so first we start from index 0. So we go with include. So then it will move on to index 1. Then we go with include. Then we move on to index 2. Then we go with include. We move on to index 3. Now if you closely see, when it is reaching to the index 3, it means array dot length, we are taking the result and we are terminating this stack frame. So when you call return, so this stack frame will get terminated. It means if you closely see, at this point in time, at max we have how many stack frames? At max, if n equal 3, so we have n plus 1 stack frames active. So we have n plus stack frames were active. So it means when n equal to 3, when I index is equal to n, then what we are trying to do, we are trying to copy this result. So this is what we are trying to do. So we are trying to copy this result, then we are terminating this stack frame. So we are terminating this stack frame. So if you closely see, so at this point in time, these are the stack frames were active. Once it is reaching base case, what we are doing, so we are terminating the stack frame. So obviously this frame will get terminated before moving on to the next logic. So you see, this is what till now we went with include. So once is include is completed, we are moving on to the exclude. We are moving on to the exclude from the current recursion call, right? So from where we terminated, from there we are moving on to the exclude. So from index 2, we terminated index 3, then this is include logic. Now we are moving on to the exclude logic with the same thing. So now again it is reaching to the base case. So once it is reaching to the base case, we copy the result and this gets terminated. Once these two gets terminated, means this complete block is terminated. Once this is terminated, we are moving on to the next case. So for I1 include logic is done, so we are moving on to the exclude. So when you are moving on to the exclude, so again you have I2, again same, I3 exclude. So it means before moving here, so this is I3, right? So you include, so it means if you closely see, even now also this is where the sub problem gets ended. At this point in time, only these 4 stack frames got activated. So by the time you move on to other subtree, this is already been terminated. This is already been terminated. So at this point in time, you have only these stack frames. So once this is completed, then it will terminate and it will start with new one. So if you closely see, at any point in time, at max only 4 stack frames get activated. So when n equal to 3, so n plus 1 stack frames got activated. So with respect to recursion, the space complexity is how much? If you closely see, with respect to recursion, what is the space complexity, please? Yes, order of n plus 1s, right? Number of stack frames or order of n plus 1, so you can take it as n. And additionally, we are storing into result, right? So we are also having the result. So that result will have 2 power n, right? So that result will internally holds 2 power n. So that's it for today. I'm sorry I took little time.